All right, our last section of chapter 10 is going to take what we did in our first section, which was about conics, and it's going to use that and to write our conics in polar form, okay? We're not going to go a lot in depth in this section. We're just going to see the relationship of the conics themselves to the relationship of polar equations. So, I didn't get my... Yeah, that's really good, but I need the... this one. I like the lines. I tend to write straighter when I have lines.
What was that title?
Ooh, we don't want that yellow. That would have been bad. Okay, we'll do this. All right, starting out with a theorem. I said definition. I totally lied. It's a theorem. Theorem 10.16. This is classification of conics by eccentricity. Let F be a fixed point, the focus, and D be a fixed line, the directrix, in the plane. And you're going to let P be another point, any other point. And E the eccentricity. And it is actually being, we've done this, defined this before, but as a reminder, it's the ratio of the distance from P to F compared to the distance from P to D. So for those of you who've done geometry lately, which is about half of you, remember that one of the ways that you can sort of think about that in terms of distance is that would be PF compared to PD. All right, we don't put lines on top of them when we're talking about distance. Distance is just a numerical a number value, right? Numerical value. So that's what the eccentricity is. The collection of all points P with a given eccentricity is a conic. So you take this ratio and you're going to get a number, right? These are numbers on top, numbers on bottom. It gives you a number. And whatever that number is, any other points going back to the directrix and going back to the distance to the focus that have the same ratio all lie on the same conic. Remember, our conics are either parabolas, hyperbolas, or ellipses. All right? And here's how you know which one it is. If the E value is between 0 and 1, it's an ellipse. If eccentricity is actually equal to 1, it's a parabola. And if that eccentricity ratio is greater than 1, it's a hyperbola. Cannot be negative because it's a distance. Remember, it's a ratio of distances. So yeah, cannot be negative. And it can't be 0 because the focus and the directrix are not the same thing, right? There is a distance between them we're comparing, all right? So circle is just a specific type of an ellipse. Yeah, it's just a symmetric ellipse, so it would count in there. So your pictures, I mean, your book has some really good pictures. I'm not a terribly great drawer on they're not three-dimensional, but when I'm working with conics. So I'd encourage you to take a look. They do a really nice job of showing you how the eccentricity would form each of these particular shapes. And when we come back next time, I have like 1 page worth of my notes, probably going to take us about 15 minutes to finish up this section, and then we'll move into review for the test, okay? So I'll adjust WebAssign. If I forget, just kindly remind me like Deborah did, and I'll fix it. But the homework for this section that we just finished, 10.5, will be due on Monday. This homework for 10.6 will be due on Wednesday when you come to take your test, and the same will be true about the WebAssigns for those corresponding sections. 10.6 will be on the test. It's very short. Like, I can give you the homework assignment now just so you have it. I mean, literally 6 questions. So yeah, the homework for this will be page 739. I mean, and WebAssign's open as well, so if you want to go and explore WebAssign, you can, but it's 15, 16, 17, 33, 36, and 38. Okay, super short. We don't know what we're doing on those yet. We will learn that next time, but this is it. Yes, 10.6 will be due Wednesday before fall break. I assume you will be having a study session because Allison asked me when we were having the test if it was for sure Monday and everything. And I let her know that we were adjusting it to Wednesday. So I assume that she's trying to get that detail worked out.
Are we free?
Yep, you're done.
It is that